Hey everybody, it's Zach again. Welcome back to another video. Today I'm going to be showing you guys how to do number 530 on Leetcode, minimum absolute difference in binary search tree, right? So the way how I would do this, I'm doing it in C++, is right away intuition when you know that the binary search that you're getting a binary search tree. And you're trying to look for the absolute difference. The minimum absolute difference is going to be the smallest difference between two elements right next to each other on a sorted list, right? On a sorted vector. So right away, once you know that it's a binary search tree, you can use the property of binary search tree that when you traverse it in in order, when it's an in order traversal, you get it's traversed in an increasing manner, right? So what we can do is we can just go ahead and traverse the whole thing, throw it into a vector, throw it into a list, and then just cycle through the list and find the minimum difference between them, and then return that, right? So usually for since an in-order traversal is a depth-first search, you want to go ahead and make a recursive function outside. So I usually just have a void explore function, or search, you can do it just like the word explore, and then we're going to go ahead and take tree node root, and then I'll also pass in the vector by reference from top down, vector of integers. Now we'll just go ahead and push all the values into this vector. And I see a way how we can make this more efficient, but we'll get to that after we tackle it first, and then I'll show you guys how we can kind of approach making stuff more efficient. So right here we want to declare a vector of integers, and then name this. We can also name it vect, and then we'll explore the tree. And then we'll go ahead, let's say now vector is a sorted array. Oops. We can just go ahead for int I is equal to, start off at 1, because we want to be comparing two numbers, and since it's going to be increasing, instead of having to do absolute value of the first minus the smaller minus the largest, we can just do the largest minus the smaller one, and that's we know that's going to be positive because there's no they're all non-negative numbers. And then I is less than vex dot size. We'll go ahead and increment I, and then min diff equal to int max, right? Because we want it to be a huge number. If it's 0, and because think about it, if we set minimum difference to 0, which is usually what we do when we initialize integers, and then let's say the minimum difference is 1, just like for this example where we have a binary search tree with 1, 3, 2, right? And the minimum difference is 1 between 3 and 2. But if minimum difference is 0, and we're just comparing, we're just taking the minimum between minimum difference and the difference between the two elements, it's always going to be 0, right? So we want it to be a really, really large number. We know the largest number that we're going to be able to hold is int max. So now we're just going to go ahead and write min diff is equal to the minimum between min diff and vect at I minus vect I, oops, daisy, I minus 1. There you go. And then right here for the in-order traversal, just going to go ahead and do our, since it's a recursive function, we always want to start off with a base case. So if our root is invalid, we're just going to return. Since it's a void function, we don't have to even return false. We'll just get out of the recursive call stack. And then since it's in order, we want to recursively call explore on the left subtree first. So root. Whoops, what am I doing? Left. And we're going to pass in our vector. And then we're going to go ahead and copy that. And then we're going to go push. We're going to go ahead and push back our current node, which is our root val. And then we're going to go ahead and explore our right tree. Alright. And this should work. This should go ahead and give us that correct answer. What am I doing here? Oh, I'm not returning minimum difference. There we go. Always make sure you're returning the correct thing. Alright, so this is correct. Let's go ahead and submit it. Perfect. It works. It's quite fast. It only takes 16 milliseconds, but it's a bit heavier on memory usage. So if you guys just wanted to see how to do it, you can go ahead and click off the video now. But I'm going to go ahead and try and make it a bit more